Okay, so this is from the first year textbook. We're looking at exercise 10F, question 1. So we've got two particles, we're given both their masses, and they're hanging over a small, smooth, so it means we don't have to worry about friction, pulley. And they're released from rest and the string is taut. So first thing we need to do is find the tension in the string. Okay, so there's my pulley, my two particles. So A has a mass of 4 kilograms, so its weight is 4g, so that's A, and B has a mass of 3 kilograms, that's going to be a force of 3g, and both of those strings will have tension. Okay, so find the tension in the string. So if I look, so the first thing to do is realise that the A is going to move downwards. So A is going to be moving down, which means B must be being pulled up because A's obviously got the greater mass. So if I look just at A, okay, so there's my force diagram for A, and that one is moving down with an acceleration of A. So using, sorry, that's particle A. So using F equals ma, and I'm going to take down this positive, 4g minus t is the total resultant force, and that equals the mass of A times its acceleration. If I then think about particle B, so particle B obviously has the same tension, so it's, we go back and check the question, yeah, so it's a light, inextensible string, so that means that the fact it's light means that the tension will be the same throughout. So for particle B, but obviously if they're connected and the string is inextensible, they're going to be moving with the same acceleration, but of course if A is moving down, B is going to be moving up. So for B, I'm going to take up as positive. So again, using F equals ma, the upward force is T minus 3g, and that equals mass times the acceleration. So now I've got two equations with two unknowns, because g isn't an unknown, g is 9.8, and they're asking me to find the tension. So I think I'm actually going to just find the acceleration first anyway, because if I add, so let's write the two equations out. Okay, because if I just add those together, the t's are going to eliminate. So I've got 4g minus 3g, so that's just g. And then I've got minus t plus t, so that's just cancelling. And that would equal 7a. So a is g over 7 meters a second squared. Okay, so now if I just go back to either of the equations, so I'm just going to use this one. So t minus 3g is 3a, and I now know that a is g over 7. And you can evaluate this at any point. So if you prefer, rather than working with 3g, if you prefer just to do 3 times 9.8 right at the start, that's absolutely fine. So t is going to be 3g over 7. So that's going to be 3 times 9.8 over 7 plus 3g. So plus 3 times 9.8. So that is going to give me 3 times 9.8 over 7 plus 3 times 9.8. And that's giving me 33.6 newtons. I'm just going to move that up a little bit so you can see it. I'll move that out of the way even. Okay. So just going to double check that is the correct answer before we move on. Yeah, lovely. Okay. Right, so then this question carries on over the page. So when A has travelled a distance of 2 meters, it strikes the ground and immediately comes to rest. Find the speed of A when it strikes the ground. So for that, I need to think about what's happening whilst the pulleys are still attached and the string is still taut. So I know, I'm looking at part B. So I know whilst the string is taut, A is g over 7. Yeah, that's what I worked out previously. The particles, I believe, were released from rest. Yeah, so that's what it said in the first bit of the question. So the particles are released from rest. So the initial velocity is 0. I'm after v, which is when it hits the speed when it hits the ground, and I'm told that it travels a distance of 2 meters. So s is 2. So I am going to use v equals u squared plus 2a, sorry, v squared equals u squared plus 2as. So v squared is 0 squared plus 2 times g over 7 times 2. So v squared is 2 times 9.8 over 7 times 2. So v squared is 28 over 5. So v is just going to be square root of that. So 2.366. And let's go to, I'm trying with the pen there, right, let's try that again. Okay, so let's go to, for goodness sake, sorry, right, we'll get there in the end. So let's go to 3 significant figures that 2 would be acceptable because we've used g as 9.8. So it's going to be 2.37 meters a second to the minus 1, or 2.4 meters per second. Again, let's just double check that answer. 2.37, lovely. Okay, and then final bit. So assuming that B does not hit the pulley. So basically what they're saying there is, let's go back to our diagram, is assume that, so B is going to be moving upwards. They're basically saying assuming that that distance is long enough that B doesn't make contact, because obviously that would change the whole thing. So assuming that B doesn't hit the pulley, find the greatest height that B reaches above its initial position. Right, so we've got to think about what's actually happening there. So once, so let's draw the sketch of our original setup. So we had a pulley and we had the 2 particles hanging either side of it, and then A is falling until it hits the ground. So once A has hit the ground, B is just going to, so B is going to carry on upwards because that's the direction it's traveling in, but it's no longer going to be pulled by the string. So once A has hit the ground, B is just going to be traveling upwards, so the only force working on it, there'll no longer be tension in the string because the string won't be taut anymore. The only force acting on it will be gravity. So after, so that's particle B. So after A has hit the ground, the mass of particle B was 3 kilograms. So the only force working on on particle B will be 3g. Or more importantly for us, the acceleration will just be the acceleration due to gravity. So I am going to take up as positive, which means that A will be minus 9.8, because obviously gravity is always working downwards. The velocity when this happens, so when A hits the ground, A and B are traveling with the same velocity. So the initial velocity for this part of the problem is 2.4. They want to know, what do they want to know? They want to know the greatest height that it reaches. So, well, when is it going to be at its greatest position? That's going to be when its velocity is 0. So basically, just to run through that again. So A is going to hit the ground. B is going to carry on moving upwards, but it's going to slow down due to gravity. So it's going to slow down, slow down, slow down until its velocity is 0, and obviously that's going to be its greatest height before it then starts dropping. So they want to know the greatest height. So again, it's v squared equals u squared plus 2as. So 0 squared is 2.4 squared, and then just be careful that you're consistent with your direction. So if I'm taking up as positive, A is minus 9.8. And if I'm taking up as positive, I'm expecting S to be a positive, because obviously its displacement is upwards. So 2A and then S, which is what I'm trying to find. So 2.4 squared. So 0 equals 5.76 minus 19.8 19.6s. So 19.6s is 5.76. So S is 5.76 divided by 19.6, so 0.294 meters, or 0.29. Let's just double check that. Okay. Oh, sorry, right, that's my fault, didn't read the question properly. So let's try that again. So that is the displacement. That's how kind of far it travels up. But they actually asked me for its height above the initial position, right? So let's be really careful there. So that's how far B travels. Let's go back to our working. So that's how far B travels after A hits the ground, but it had already travelled up 2 meters. So the total displacement from its initial position is going to be that plus 2 meters. If I round that to 2 significant figures, that's 2.29 meters. Yeah, that's a bit more like it.